Yo, gather round, time to learn, no delay. Real numbers in the house with it today.
What? Oh, come on. Ugh. Unlock the number line? What does that even mean?
I've tried everything, even pressing every button on this thing. Nothing works.
Luke, there are numbers, and even some weird symbols. I'm calling Miss Sparks for help.
Miss Sparks, sure bet can help.
Aha, okay.
Will we unlock the number line?
No need to panic, guys. Let's spark activate.
Hey, adventurers! Need help cracking this level?
Ooh.
Wow. Miss Sparks, can you help?
Hey, adventurers. Stuck at this level? No worries, I've got ya. To unlock the gate, you need to master real numbers. These are numbers that define almost everything around us. They all live on this number line, split into two powerful teams. These are rational and irrational numbers. Rational numbers include fractions, whole numbers, and decimals that either terminate or repeat, while irrational numbers are numbers like pi and the square root of 2 that never terminate or repeat. Let's explore how real numbers show up in your everyday life.
Whole numbers, integers, salad crew, positive, negative, 0, 2, no fractions, weird, last a roll, keep this roll, keep the cool, has to go. Real deal numbers, they run the town, decimals, fractions, up and down, from rational to irrational sound, these are real numbers all around.
Let's break down rational numbers on the basketball court. Shooting from the free throw line, 15 feet. That's a whole number. This is a type of rational number. If you shoot from 7.5 feet, it's a decimal that ends, which is also rational. If you make 3 shots out of 5, that's a fraction. We would refer to that as 3/5. This too is a rational number.
I did it, Miss Sparks. I scored. Go for it, Max. You can do this.
I can take this shot. I can do this. I can do this.
Awesome job, Matt. You did it. Yay!
Real numbers, real fun, count them one by one, no matter where you run, real numbers all we need.
Now, let's talk irrational numbers. Imagine slicing this pizza into 10 pieces. Each slice is 1/10. This is a rational number. But if we measure the pizza circumference using pi, which is 3.14159265335, oh my, I'm getting tired. It never stops. The decimal goes on forever, making it an irrational number.
OMG! Math and pizza? Yummy! I am irrationally in love with pizza.
No lie, Nia. This pizza is fire. And that example with pi? Yeah, I finally get irrational numbers now. They just keep going forever. No repeats. Kinda wild. But now I'm wondering, where else do we actually use them?
I have no idea. But you already know Miss Sparks is about to drop some knowledge on us and break it down. She is slay.
All right, let's skedaddle out of here and explore how irrational numbers appear in different aspects of life.
Forever, no stopping, no sign, no fraction can hold me, no border, no line. Try to divide me, I'll slip through your hands.
All right, look around. Trust me, irrational numbers are hiding in plain sight. Ever thought a simple post-it could reveal something irrational? Watch this. Look closely. Each side of this post-it note is exactly 1 unit long. But what if we measure the diagonal, which is the line that cuts across the square from one corner to the opposite corner? Let's find out.
Miss Sparks, how do we figure out the length of the diagonal?
Great question, Leah. Using the Pythagoras theorem, we find that the diagonal is the square root of 2.
Wait, square root of 2? Isn't that one of those irrational numbers?
Told you it was wild. But seriously, it's kinda cool that something as simple as a sticky note can show us math.
Whoa! This STEM lab is amazing!
Max, you are so crazy.
I'm so glad you're all having fun while learning. You guys picked up so much in such a short time. You're really getting the hang of real numbers. Ready for a challenge?
Absolutely! Let's do this!
Okay, let's see what you've got. Look at these numbers floating here. Can you drag them into the correct order on the number line? We've got -3, 0.75, 2 times the square root of 2, pi, 12.5, and 44. Pay close attention. Some are fractions, some are decimals, and a couple are irrational. Ready? Let's see if you can unlock this number gate.
Let's group them. Whole numbers, fractions, decimals, and the irrational ones like pi.
Oh, and don't forget, drop your answer in the comments to help us open the number gate.
All right, let's start with our smallest number, -3. It's a negative number, so it's less than 0. It's also a whole number, just on the negative side.
Next up is 0.75, that's a decimal, and it's just a little less than 1. Since it's more than -3 but still less than the others, it comes right after.
Now it gets spicy. Next up, we've got 2 times the square root of 2 and pi. These two are irrational.
All right, next up 12.5. It's a fraction, and it comes after the irrationals. And finally 44. That's a whole number and the biggest one in the group.
Awesome! All done!
Run the town. Decimals, fractions, up and down. From rational to irrational sound. These are real numbers all around.
We did it! Amazing!
Rationals elite fractions, that's the key. Repeat events and of the guy legacy. From 1/2 to 0.5, it's randomly. Countless ways to show them mathematically.
Let's do a quick recap of what we learned today. Natural numbers are counting numbers starting from 1, and whole numbers are counting numbers plus 0.
Rational numbers are fractions and decimals that end or repeat, while irrational numbers are decimals that never end or repeat, like pi.
Real numbers are all numbers that can be plotted on a number line. Who knew math could be this epic? Hit like and subscribe for the next Math Quest adventure.
Oh, by the way, check out the quiz in the description box below to test what you learned today. And if you've got any questions or cool math thoughts, drop them in the comments.